The purpose of this video is to describe the use of the TI84 for computations involving the binomial distribution. The binomial distribution describes the probability of getting a certain number of successes out of a fixed number of tries when the probability of success remains constant between each attempt. In our example here, where we've plotted the binomial distribution for the in-captivity breeding of panda bears, where it's the distribution of the number of successful births in 25 attempts, where the probability of success is fixed at 8% on each attempt. As we can see, it's very likely to get none or one or two or three successes in 25 tries, but very, very unlikely to get more than 8. And we can compute these values using the TI84. So let's start with the first example, the probability of getting exactly 3 successful births out of 25 attempts. Well, that's what the function binomial PDF is for. We can find it on the TI84 under the distributions, where we find normal distribution and many other functions. So to get there, it's second vars, or second distributions, and we cursor down until we get to binomial PDF for probability density function. In this case, it would be a probability mass function. So binomial PDF, the first thing we put in is the number of tries, followed by the probability of success on each try. Remember, the trials have to be independent for this to work, which means the probability remains fixed. And then we put in, the last thing we put in is the number of successes that we want. So this will compute the probability of 3 out of 25 successes. And it gives an answer of 0.18807, and that corresponds to the the fourth bar here, probability of 3. Notice it's about 0.188. We can similarly compute the probability of getting exactly 10 out of 25 successes the same way. Second distribution, binomial PDF, 25, comma, the probability of success each time, 0.08, and now 10. And notice this will be a much smaller number. It's actually 1.0 times 10 to the negative 5, or if we wrote that number out, it would be 0.00001. Right? So a very small probability, and that makes sense because we're way out here on the chart, where if we only have an 8% chance of success, it's very unlikely that we'll get 10 out of 25, or 40% success rate in my sample. So the next problem we can work is the probability of getting 2 or less successes out of 25. That would be adding up these first 3 probabilities. And we could do it directly by computing binomial PDF for 0 out of 25, followed by computing binomial PDF for 1 out of 25, followed by the same one for 3, and adding them all up. But there's a nice built-in function for doing this. It's called binomial CDF for cumulative distribution function. So it's second distribution, binomial CDF, and it has the same form. We put in the number of tries, the probability of success, and then the number up to and including. So this is up to and including 2, so this will compute the probability of getting 2 or less successes in 25. And that's 67%, and you can see we're adding something close to 12%, and then maybe 26% and 28%. So that's what it's done for us. So probability of 2 or less is very high, 67.68%. What about bigger than 7? Well, we don't have a function for doing this. Binomial CDF only works with the number up to and including, so we need to use the complementary probability. So what I need to do is, if I don't have more than 7 or more, I must have 6 or less. So I can compute this last one using the idea of complementary probability. It's going to be 1 minus the probability of getting 6 or less, which is second distribution, binomial CDF. Again, the number of tries is 25. The probability of success is 0.08, and we want to eliminate all the possibilities up to and including 6, and what's left over will be the probability of 7 or more. And there it is, about only 0.00277, or about 0.28%, about 1/4% probability of obtaining 7 or more successes. So that's the use of binomial PDF and binomial CDF with the TI84.